So now we will get into the clustering techniques, and for clustering we'll be using the k-means. Now this part of the code has been inspired by this good post. A lot of code has been taken from this, so you can visit this whenever you want. So let's get into the clustering method. So first what we will do is, as you know, in any clustering method, the most important thing is to understand how many clusters to use. What is the most optimal value of the clusters we use. So for this we implement something called the elbow method. So what we will do is, we are the number of clusters is like a hyperparameter which we want to understand, and we will use this elbow method for understanding what is the right optimal amount of clusters. So what we'll do is, we will build 10 different clusters, and then see what is the squared error for each of those clusters. We'll fit the recency data for each of those clusters and then find the squared error, and based on the squared error we visualize the squared error with respect to each of these clusters, and then from that we will see the determine which is the most optimal amount of clusters which is required, a number of clusters which we require. So let's implement that. So first we have a dictionary to store the squared errors, and recency is the variable which we will use to build our clusters. So we'll take the recency variable from our data set, the small data set which we earlier extracted here, and then we'll build a iterative loop from 1 to 10. So 10, we're trying with 10 different clusters. So we fit the k-means, we give the number of clusters equal to k, as and when within the range from 1 to 10 we give the clusters. You give a maximum iterations of 2000. So these are some hyperparameters which you can change at your the way you want. So I've just used 2000. You can make it different also, and then fit the recency data. The recency data is fit, and then we store the squared error in the dictionary against that specific cluster. So the cluster is your key, and the value is your the value, the squared error value. So now once this is run, let's run this, and then we are plotting it. So we get a plot like this. So we, against, on the x-axis you have the number of clusters, and y-axis you have the squared error, and you can see that how the squared error decreases with the number of clusters. Obviously with more number of clusters the squared error will keep on reducing, or it will just plateau after a certain point of time. So the elbow method means says that wherever there are big changes, that would be the ideal kind of clusters which we require. So the big change happens at 2, then there is a slight change in 3, and then 4. So it's like the elbows of your hand. So you can either adopt 2, 3 or 4. What we'll do is, we'll take 4 as the number of clusters which we want, which we will see because it's only as a method to build our states. So what we'll do is, let's have a little more variability or a little more number of states, and therefore we'll adopt 4 number of clusters for our purpose. So we have identified that 4 is the ideal or the number of clusters which we want. Now once we have identified the number of clusters, the next is about fitting the data with that amount of clusters. So again we'll use k-means to fit the number of clusters. Now now we have defined the number of clusters as 4, and then we fit the recency data with the k-means method, and then we will predict which of these users, or which of these users are based on the recency falls under which cluster. So that is what we do. So that's what this code says, and then let's implement this. So this is the output which we'll get. So here each customers against which cluster which are they coming under. So we have 4 clusters, which is ranging from 0 to 3. So that's flow 0, 1, 2 and 3. 0, 1, 2, 3. So 4 clusters. So you get so the data set will be like this. Now let's do one thing. Let's reset the index and then sort the data according in a ascending order, and just sort this so that according to clusters we get the customer ID. So let's do that and we get this. So why we are doing this is also to understand whether there is a logical order in which the clustering is done. So let's what we'll do is we'll just group by the recency cluster. We'll just do group the based on the recency cluster, and then take the mean value of the recency, the mean value of recency, and then let's implement that. Let's find what we find. So this is the results which we get. So let's look at the let's look at the results a little bit closely. Now what happens is we have these clusters 0, 1, 2 and 3, and then the values, the mean value of the recency data. Now if you can see that this is all over the place. That is the first the cluster 0 has recency 115, and then next is the largest cluster is in recency cluster 1, and then smallest is in recency 3. So what we will do is next because we later on when we combine these clusters together of recency, frequency and monitoring, we need to have this as a logical order. The logical order is, say, with increasing number of clusters, either it should be the increasing amount of recency, or the other way around. Some logical order we need to have. So we will implement a specific function later, right now after this, to get this into a specific order we want, in a logical order. So that's what we will do next. So we'll implement a function to sort the clusters in a logical order. Now why we do it as a function is because we will have to do the same process for the monetary value and the frequency value. So let's understand this function which we are going to implement. So the inputs to the functions are the cluster field name. So this is the field name we give to the cluster in the data, like say for example the recency cluster, or later on the frequency cluster, or the monetary cluster, etc. So these are the field names which we give for the cluster. Now the next input is the target field name. So this is the data pertaining to the values which we want to cluster, like your recency, your frequency and monetary. The earlier one is just a name which we want to give as the recency cluster. The next is the actual field name which we want to sort. Data is obviously the data frame which we've given, like say for example your user recency data frame or monetary, etc. So the next is a flag, whether indicating whether we want to sort it in the ascending order or the descending order. So this is just a binary kind of a flag which we will give later on. So the first process which we do is we group the data based on the cluster, and then summarize the data under each group to get the mean of the target variable. Now the idea is to sort the data frame based on the mean values in the ascending order, which is done, and which is done in the next line. Okay. So once the data is sorted in the ascending order, we form a new feature with the data frame index as its value in the next line. So this is what we will do, this particular line. Now the index values will act as a sorted cluster values, and we will get a mapping between the existing cluster values and the new cluster values which are sorted. So and in the next line we merge the summarized data frame with the original data frame, so that the new cluster values are mapped to all the values in the data frames. So that's what we do it here using the merging function here. So once the new sorted cluster labels are mapped to the original data frame, the old cluster labels are dropped in line in the next line, and the column is renamed in the next line. So that is all what the function is. So we will implement this function. Maybe you can just pause for a little while and then go through the code again and then understand it in better. Okay. So now what we'll do is we have created that function, and then using that function, let's sort the recency data in a logical order. So we just implement that. So here we use the function order cluster which we created. Recency cluster is the field name. Recency is the data which we use. User recency is the data frame which we use. And for the flag as ascending or descending, we give as false. That means we want to sort this in descending order. So let's implement this, and then let's also kind of look at the data. How is it been sorted? Let's again group these data based on the recency cluster, and then the recency value, and then find the mean of those values. Let's implement that. So this is the data which we get after this. Now let's look at this closely. Now we have your clusters in the descending order from 0 to 3, and then you also see that the recency values have also been in a logical order, that is in a descending fashion. That is cluster 0 where the recency value is the highest, and the cluster 3 is the recency value is lowest. Now from a business perspective also, let's look at it. What is important. Now cluster 0 are those people who are not recent at all, because who have come at a very distant date, who have visited the store in a distant date. And cluster 3 is where the customers have recently visited. So from a recency perspective, cluster 3 and is the best cluster. And cluster 0 is obviously the worst cluster, because they have visited not in the recent past, but their last visit has been in far away. So that's this logical order in which we have done this. So since we have to do the same process for the monetary and the frequency also, so we will wrap all these processes which we have seen so far, right from fitting the number of clusters into sorting everything into another function. So all these processes which we have implemented so far, we'll just put that in the cluster. Now all these things are things which you have already seen. That is, first is we subset the data based on the field name which we want, whether it's recency or frequency or whatever, and then we build the k-means, number of clusters we give, fit the data, fit the k-means cluster, and find the number of clusters. You also define what is the cluster field name, which is your target field name plus cluster. So that's like your recency cluster or frequency cluster, etc. And then you predict what is the cluster number of clusters for each of those customers. Then you use your sort based on the ascending or descending user variable, and then you implement the based on the sorted values, you implement the order cluster function which we earlier created. So the final and we return the final sorted the cluster values, or the data frame with the clusters. We that's a variable which is, or the data frame which is returned. So this is the overall function. You can just pause this and then look at this function again and understand each part of the code.